लिखा characteristics of equilibrium constant. Characteristics of equilibrium constant. KPA হোক বা KCA হোক, what are the different characteristics of the equilibrium constant? Point number 1, the equilibrium constant has a definite value for every chemical reaction at a particular temperature. The equilibrium constant has a definite value for every chemical reaction at a particular temperature. Jikono eta reaction or the one which has attained equilibrium has a fixed value of equilibrium constant provided temperature is fixed. The value of equilibrium constant is independent of initial concentrations of the reacting species. তার মানে ইনিশিয়াল কনসেন্ট্রেশন কি হয় রিঅ্যাক্টেন্ট বিলাগৰ তার উপর ডিপেন্ড নকৰে no matter whatever be the amount of reactant you are adding up, equilibrium to যেতিয়া পাব হব তেতিয়াহে পাব irrespective of the equilibrium, the initial concentration of the reactants. Point number 2, the value of equilibrium constant changes only with change in temperature. তার মানে if you change the temperature of the reaction, then only the equilibrium constant will change. Otherwise, the equilibrium constant value is always fixed. Point number 3, if the equation representing equilibrium constant is reversed, the new equilibrium constant is inverse of the first value. Is inverse of the first value. What does that mean? তার মানে কি? Suppose you have an equilibrium reaction A plus B reversible C plus D, and if the equilibrium constant for this reaction is X, if you reverse this reaction, if you write C plus D reversible A plus B, then the equilibrium constant for this one will be 1 by X. Is it clear?
Yes, sir.
So this is one of the very important relations that যেতিয়া তুমি এটা equilibrium reaction ok ulta koi likhiba tetia equilibrium constant tar inverse hoye jabo, reciprocal hoye jabo. It will be reciprocal of the initial value. Hoise, first point have you written down? Can I rub it?
Yes, sir.
Okay. Momi, written the first point?
Yes, sir, written.
Okay. Point number 4. If the equation is multiplied by a factor n, যদি এটা particular equilibrium reaction আমি multiply করু by factor n, then the new equilibrium constant is the nth power of the previous value. Nth power of the previous value. তার মানে কি? What does that mean? Let us see. Suppose we have a reaction A plus B reversible C plus D, and the equilibrium constant for this one is X. Say, if you multiply this whole equation by any number, then the equilibrium constant, the new equilibrium constant will be raised to the power that number. Okay, so if you multiply any number all through, then equilibrium constant juntu notun hobo, that will be the original value raised to the power the number with which you have multiplied. Clear is it?
Yes, sir.
Okay. हो गया? Can I proceed?
Yes, sir.
Okay. Point number 5. If two or more equations are added up, their equilibrium constants are multiplied. So if you have, suppose, two equilibrium reactions, A plus B, reversible C plus D. Say its equilibrium constant is X. If we have another equilibrium, C plus D is equal to E plus F, and its equilibrium constant is Ky, K equal to Y. If you add it up, so we know that C and D will mutually get cancelled. And when C and D are getting cancelled, ultimately the equation that you get is A plus B reversible E plus F. So what will be the new equilibrium constant? When you add up the two reactions, you are supposed to multiply the two equilibrium constants. The same way, when you subtract the two reactions, two equations, then the equilibrium constant will be divided. So if reactions are added, equilibrium constants are multiplied. If reactions are subtracted, then equilibrium constants will be divided. Understood?
Yes, sir.
Okay. Point number 6. The value of the equilibrium constant is not affected by the addition of a catalyst. Is not affected by the addition of a catalyst, as the catalyst increases the speed of both the forward and backward reactions to the same extent So we know that whenever we add any catalyst speeds up the reaction. But why the catalyst has no effect when you are adding up at equilibrium, because both the forward and backward reactions are affected to the same extent. Okay, so when you are considering the forward reaction, that is also affected, and equally the backward reaction is also affected to the same extent. So ultimately দুয়োফালে যদি rate of the reaction একে ধৰণৰ increase হৈছে, তো net resultant তো no change হ'ব নহয় জানো?
Yes, sir.
তো সেইকাৰণে the catalyst has no effect on addition at equilibrium. I hope the points are clear.
Yes, sir.
Okay. So when we talk about all these properties that we have discussed, so how to apply these properties to carry out the question? Let us try to find it out. Suppose you are given a question. Consider the reaction consider the reaction N2 gas plus thrice H2 gas reversible twice NH3 gas, whose Kc value is say 49. Okay, Kc value 49 দিয়া আছে। প্রশ্নটো হল ক্যালকুলেট the equilibrium constant for the reaction NH3 gas half N2 gas plus 3/2 H2 gas. So how you are going to calculate the Kc for this reaction with the help of this? So in order to understand it, compare the two reactions and tell me what are the changes you have made in this particular reaction. If you want to get this from this, কি change কৰিব লাগিব, কি কৰিছো আমি?
So equation is reverse.
Equation to reverse কৰিছো, এইটো এটা কাম কৰিলো, আৰু কি? আৰু কি কৰিছো?
So half factor is multiplied.
আমি হাফ এৰে মাল্টিপ্লাই কৰিছো। তাৰ মানে এই দুইটা যদি আমি চেঞ্জ কৰো original equationত, তেতিয়া আমি এই equationটো পাম। And same way, by applying the properties just now discussed, we will be applying it on Kc. So how will we proceed? So আমি original equation to লওঁ, N2 gas plus thrice H2 gas reversible twice NH3 gas লৈছো। So Kc is given to be 49. তো যদি মই এই রিঅ্যাকশনটো উল্টা কৰো, বাকি কোনো চেঞ্জ নহয়। If I reverse, then what will be the effect on Kc? উল্টা কৰিলে ইকুইলিব্রিয়াম কনস্ট্যান্ট টু ইনভার্স হৈ যায় নহয় জানো? ঠিক আছে, বুঝি
Yes,
পাইছা?
sir.
Okay. Now, in order to get this, I have to multiply the whole of equation with half. So multiplying with half, we will get NH3 half of N2 3/2 of H2. So just now we have discussed that jodi tumi eta number ere gute equation to multiply kora, then the equilibrium constant that you are going to get will be raised to the power that number. So since we have multiplied all through with half, so here it will be raised to the power half. So will it not be equal to 1/7? Yes or no?
Yes, sir.
Okay. Is it clear, everyone?
Yes, sir.
Okay. So তেনেকুৱা ধৰণৰ question তুমি expect কৰিব পাৰা, either only one property will be applied or more than one properties have to be applied. But in order to get the answer, what you are supposed to do is you apply properties one after another and accordingly make the changes in the value of Kc. There will be no confusion. Okay? Can I proceed?
Yes, sir.
Yeah, okay. So after discussion of the characteristics of equilibrium constant, the next thing that we are going to discuss are the type of equilibrium. Types of chemical equilibrium. So chemical equilibrium can be further subdivided into two types, remember. One of them is called homogeneous equilibrium. Homogeneous equilibrium. Now, what is homogeneous equilibrium? If all the reactants and products that are taking part in equilibrium have same phase, okay, if all of them are gases, means nobody is solid or nobody is liquid. If all of them are liquids, then everyone is in the liquid phase. So if all the reactants and products are in the same phase, then it is referred to as homogeneous equilibrium. Is it clear or not? বুঝি পাইছা নে?
Yes, sir.
If all the reactants and products of an equilibrium reaction are in the same phase, the equilibrium is called homogeneous equilibrium. Homogeneous equilibrium. Say for example, H2 gas plus I2 gas reversible twice HI gas. Okay, so here all the reactants and products are in the gaseous phase. So if in a reaction, all of them are in the same phase, doesn't matter whether it is liquid or solid. Suppose we have CH3COH liquid plus C2H5OH liquid so here you see all the reactants and products are in the liquid phase. In the first one, all of them are in gaseous phase. In the second one, all of them are in the liquid phase. But if the phases are different, they do not belong to the same phase, then they will be called as heterogeneous equilibrium. Heterogeneous equilibrium. It will be same definition. Khali difference to ki hobo? The reactions are not in the same phase. If all the reactants and products of an equilibrium reaction are not in the same phase, then they are called heterogeneous equilibrium. Say for example, calcium carbonate solid, calcium oxide solid, carbon dioxide gas. So here you see that all of them do not belong to the same phase. Calcium carbonate is in the solid state. Calcium oxide is also in the solid state. But carbon dioxide is in the gaseous phase. Okay? Is it understood? Homogeneous, heterogeneous to বুঝি পাইছা তো?
Yes, sir.
Yes, sir.
Yes, sir.
So how to write down the equilibrium constant expression for any heterogeneous equilibrium? Heterogeneous equilibrium or karne jodi equilibrium constant or expression to bonabo lage tetia hola khoday monot rakhiba that when we are writing Kc expression on solids should not be considered, only gases and solutions should be considered. And while writing the expression for Kp is meant for gases only. Only gaseous substances are to be taken into consideration. Don't consider any other you can say reactant or product. So when we are writing the concept of, when we are writing the expression for Kc, who should be considered? Solutions and gaseous substances. And while writing the Kp, who should be considered? Only gases should be considered. So write down the next topic as equilibrium constant of heterogeneous system. Equilibrium constant of heterogeneous system. Heterogeneous equilibria often involve pure solids or liquids. But concentration of pure solids or liquid is constant. Therefore, we consider the concentration of such entities as unity. We consider the concentration of such entities which are pure liquids or pure solids as 1. So when we consider a reaction calcium carbonate solid, reversible calcium oxide solid, carbon dioxide gas, so here the solid should not be taken into consideration. So therefore, the Kc expression should be only concentration of carbon dioxide. We should not consider the other two because the other two are what? Solids. The solid or ami ketiao concentration nodhoru. Thik tenekwa ke Kp, which is meant only for gases. So it will be only partial pressure of CO2 because partial pressures of solid entities do not make any sense. Bujhi paisa na?
Yes, sir.
So hence, while writing Kc, concentrations of solutions and concentration of gaseous substances are considered. And while writing Kp, partial pressures of gases are only to be considered. Okay, can I proceed? আগবাড়িব পাৰো নে?
Sir, can you explain again?
তার মানে concentration term to যেটি আমি লিখিম concentration of only solutions, aqueous solution কোয়া বা gaseous substances আমি লিখিম. We were expecting the Kc expression for this reaction to be what? Calcium oxide আৰু carbon dioxide ওপৰত হ'ব লাগিছিল নহয় জানো আৰু calcium carbonate তলত হ'ব লাগিছিল, isn't it?
Yes, sir.
কিন্তু যেহেতু ক্যালসিয়াম অক্সাইড আৰু ক্যালসিয়াম কার্বনেট সলিডস হয় তো সিহঁতৰ কনসেন্ট্রেশনটো আমি 1 বুলি ধৰিছো তো অকল কার্বন ডাই অক্সাইডে থাকিব বুজিলা
Yes, sir.
আচ্ছা ঠিক তেনেকুৱাকে কেপিৰ কাৰণে we were expecting this expression, isn't it?
Yes, sir.
কিন্তু these are solids তো solids অৰ তো কোনো partial pressure নাথাকে partial pressure তো অকল গ্যাস বিলাকৰে থাকে তো এটো আমি নেগলেক্ট কৰিছো তো অকল partial pressure of carbon dioxide থাকিব না না
Yes, sir.
understood?
Yes, sir. Understood.
Okay, so you will understand it better when we do some more examples that how to write down the expression for Kc and Kp. Kc আৰু Kp ৰ expression to কেনেকে লিখিব লাগে এটো ভালকে গম পাবা question to লিখা write the expression of Kc for the following reactions. Kc ৰ expression to লিখিবলৈ কৈছে. Number 1, twice NOCl gas, reversible, twice NO gas plus Cl2 gas. ইয়াত গোটেইকেইটা gaseous হয় and Kc expression যেতিয়া আমি লিখিম, so gases should be considered as I told you. তেতিয়া হলে Kc expression to কি হ'ব? Third bracket NO square into third bracket Cl2 divided by third bracket NOCl square. Clear?
Yes, sir.
বুজিছা ন?
Yes, sir.
Number 2, 2 moles of copper nitrate, which is solid, reversible, 2 moles of copper oxide, which is solid, 4 moles of nitrogen dioxide, which is gas, 1 mole of oxygen, which is gas. So if you are asked to write down the expression for Kc, how you are going to write down? The solid should not be considered. So accordingly, what will be the expression for Kc? It will be third bracket NO2 to the power 4 into third bracket O2, nothing else. Isn't it? Bujisa?
Yes, sir.
Yes, sir.
Sir,
Hmm.
aqueous solution থাকিলে consider কৰা হ'ব ন?
Pure liquid বা pure solid যদি হয় তেতিয়া consider কৰিব নালাগে. ঠিক আছে? Can I proceed?
Yes, sir.
Okay. আৰু এটা লিখি লোৱা তেতিয়া confusion টো যাবগে. CH3COO-C2H5 aqueous plus H2O liquid CH3COOH aqueous C2H5OH aqueous. So those we have written as aqueous, only they should be considered, and water being a pure liquid should not be considered. তেতিয়া হলে Kc expression কি হ'ব? Third bracket CH3COH, third bracket C2H5OH, third bracket CH3COO, C2H5. Clear? Is it understood?
Yes, sir.
So aqueous solution should be considered because solutions have concentration. Pure liquids or pure solids do not have any concentration. Acha, ইয়াত যদি Kp2 লিখিব দিলে হয়, if I would have been asked to write down the expression for Kp, even though it's not asked, so still the Kp depends only upon the gaseous substances. Those which are gaseous, only they are going to come out in the expression. So Kp for this one will be partial pressure of NO square partial pressure of Cl2 divided by partial pressure of NaCl square, because all are gaseous. Here also Kp will be partial pressure of NO2 to the power 4 into partial pressure of O2. There is no denominator. And coming to the last one, there is no expression for Kp. Kp does not exist for the last one because there is no gaseous substances. Kc is there, but Kp is not there. Now is it understood?
Yes, sir.
Okay. Is it clear to everyone? Kp aru Kc kun kun thakibo lage kun kun nohoy?
Yes, sir.
Okay. Can I proceed further? Have you written it down?
Yes, sir.
The next thing that we are going to discuss, which is sometimes asked in entrance exams and other different type of exams, what are the units of equilibrium constant? So equilibrium constant is something whose unit varies from reaction to reaction. So let us see units of equilibrium constants. KPa होक व KCA होक. The units of Kc and Kp depends upon delta Ng. What is delta Ng? It is change in the number of moles of reactants and products. Suppose you have a reaction twice NO gas, equilibrium with N2 gas plus O2 gas. And you are asked that what is the unit for Kc? So Kc expression is third bracket N2 into third bracket O2 divided by third bracket NO square. So if you look at it, the number of moles per liter, because concentration means moles per liter. So every concentration term will have unit of moles per liter. Moles per liter. And this one will be moles per liter square. So ultimately you will see that there is no unit of Kc, nor there is any unit of Kp. Partial pressure of N2 into partial pressure of O2 divided by partial pressure of NO square. So what is the unit of pressure? ATM hobo pare, bar hobo pare. But whatever be the unit at the top, same will be the unit at the bottom. Which means that for a reaction in which delta Ng is 0, there will be no unit of Kp and Kc. Kp aru Kc kuno unit nai. But delta Ng not equal to 0 jodi hoy, tetia hole hai kiba eta unit hobo. Only if delta Ng is not equal to 0, there is change in the number of moles, comma then the unit of number one Kc. Kc unit ki hobo? It will be moles per liter to the power delta Ng. And Kp unit ki hobo? ATM or bar to the power delta Ng. Okay. So for the reactions where there is no change in the number of moles of gaseous substances, Kp and Kc won't have any unit. They are dimensionless. They are unitless. Only if there is a change, you are going to get the unit of Kp or Kc. Clear or not?
Yes, sir.
Others, is it understood?
Yes, sir.
Okay. Can I proceed further?
Yes, sir.
Okay. So after discussion of units of equilibrium constant, characteristics of equilibrium constant, the next thing that we are going to discuss is applications of equilibrium constants. Applications of equilibrium constants. There are two important applications of equilibrium constant. The first important application is prediction of by predicting the extent of a reaction. Okay, now what's the meaning of predicting the extent of a reaction? See, there are some reactions which attain equilibrium just after the reaction starts. একদম আরম্ভণীতে equilibrium to আহি যায় আর এবার equilibrium to আহি গলে we know that the reaction does not further proceed. Okay, it seems as if it has stopped as the rate of forward reaction becomes equal to rate of backward reaction. Some reactions attain equilibrium just before the end of the reaction. Reaction to শেষ হবই হৈছিল তেতিয়া equilibrium to পাইছে. And there are some reactions where equilibrium is established somewhere in between. Okay, আধা আধি গৈছে reaction to তার পিছত equilibrium to attain কৰিছে. So at what moment of time the equilibrium is achieved can be predicted on the basis of the equilibrium constant. কেনেকে? Suppose আমি Kc লৈ explanation to কৰো. If the value of Kc is greater than 10 to the power 3. Now, what is the meaning of the term 10 to the power 3? 10 to the power 3 whole 1000 by 1. Tell me who is present in the Kc expression in the numerator? Is it the product or is it the reactants?
Products.
Products. So products uporot ase, reactant tolot ase. If you compare their concentration, the products are 1000 times more as compared to the reactants when equilibrium is established, isn't it? So when products are 1000 times more with respect to reactants, so what can you say about the extent of the reaction? At what moment of time the reaction has been achieved? Is it not just before the end of the reaction where most of the reactants have already been converted to products? Yes or no? Products predominate the reactants. Products predominate the reactants. মানে প্রোডাক্টৰ মাত্রা রিঅ্যাক্টেন্টৰ তুলনাত বহুত বেশি when equilibrium is achieved. That is the equilibrium is achieved almost near the completion of the reaction, isn't it? Reaction to শেষ হ'ব হৈছিলে কাৰণ একদম completion or ফালে products are found to be in much more larger extent with respect to the reactants. If the value of Kc is less than 10 to the power minus 3. আচ্ছা, less than 10 to the power minus 3 মানে কি? মানে 1/1000. 1/1000 এতকৈ কম. So here, who is present in large amount when equilibrium is established? Tell me. Products or reactants? Reactants. So reactants ইমান বেশি, product একেবারে কম, তার মানে equilibrium যেতিয়া establish হইছে, reaction to just আরম্ভ হয়েছিল, isn't it? কারণ আরম্ভণিতে reactant বহুত মাত্রাত থাকে, product একেবারে কম মাত্রাত থাকে। বুঝি পাইছা?
Yes, sir.
Yes, sir.
Reactants predominate the products. At what stage the reactants predominate the products? That is the equilibrium is achieved almost near the start of the reaction. তো value of Kc যিমান বেশি হব, ইমানে আমি কব পাৰো যে reaction is attaining equilibrium just before the end of the reaction. আর যিমানে কম হব Kc, তার মানে the reaction attained equilibrium at the very outset, একদম আরম্ভণিতে। And মাঝামাঝি যদি থাকে, if Kc lies between 10 to the power minus 3 to 10 to the power 3, এই দুইটার মাঝামাঝি যদি থাকে Kc এর ভ্যালু, the reaction attains equilibrium somewhere in the midst of reaction. Reaction or করবার মাঝামাঝি, যত reactant to ইমান বেশি নহয়, product to ইমান বেশি নহয়, they are comparable, so equilibrium is established somewhere in between. I hope it is clear now. বুঝি পাইছা নে?
Yes, sir.
Okay. Write it down so that we can move on to the second important application. The first important application is predicting the extent of reaction. Reaction to কিমান খিনি গৈ পাইছিলে when equilibrium was established. हो गया? Can I rub it?
Yes, sir.
Okay. Now, last class, I told you something about QC, that is reaction quotient. So reaction quotient expression wise is same as that of Kc. But the difference between the two is, whereas only at the point of equilibrium, the ratio is called Kc. And if the reaction is not at equilibrium, the same ratio will be called as QC. So this will be application number 2. Predicting the direction of reaction. Okay, so if the reaction is not at equilibrium and the concentration of reactants and products are known to us, so comparing it with the equilibrium constant, which will be also provided to us, how can we predict the direction of the reaction? So we can write for any reaction, for any reversible reaction, reaction quotient denoted by QC is the ratio of the molar concentrations of the products to that of the reacting species. At any stage of the reaction. At any stage of the reaction. যে কোনো stage of এটা reaction আছে, suppose A of A plus B of B reversible C of C plus D of D. The reaction quotient QC this is the expression for QC. Now, when Kc value for any reaction is given to you and QC is calculated at any point of time, and then we compare the values, we can say if QC value is less than that of Kc, that means the reaction is not at equilibrium. And if the reaction is not at equilibrium, it will try to achieve equilibrium, and to achieve equilibrium, reaction will proceed in forward direction. To achieve equilibrium, the reaction will proceed in the forward direction. Number 2, if QC is greater than Kc, the reaction is proceeding from the backward direction. The products are more with respect to the reactants as compared to what is required to achieve the equilibrium. To achieve equilibrium, reaction will proceed in backward direction. Now, what if QC and KC values are equal? Will it move to any direction?
No, sir, it is
No.
equilibrium.
Because it is already at equilibrium. So already jodi QC aru KC value সমান আছে, then the reaction is not going to move anywhere. So it is at equilibrium. ঠিক আছে, বুঝি পাইছা?
Yes, sir.
তো এখানে লিখি লোৱা. Then we are going to proceed to discuss a very important topic as far as the numericals are concerned. Can I proceed? Done?
Yes, sir.
So after discussion of applications of equilibrium constant, I'm going to choose some common equilibrium reactions which are most often asked, and I'm going to write down the expression for the KC and KP, and you must learn how to write down the expression of KP and KC for such reactions, which will help you to understand at least how to do the numericals based on equilibrium. So write down the next topic as expressions of KC and KP for some common equilibria. For some common equilibria. So কেইটামান common equilibrium আছে. Equilibrium is a singular word. Equilibria is a plural. So we are going to write down the expression for KC and KP. How we are going to write down? Let us see. So at first, let me take the equation H2 gas plus I2 gas reversible twice HI gas. So as we can see, it's a special type of equilibrium reaction where there is no change in the number of moles. Delta Ng is 0. And we know that if delta Ng is 0, then Kp and Kc will be equal for such kind of expressions. So what do I do is, let us say that when the reaction did not start, time was 0, we start away with A moles of H2 and B moles of I2, and there was no product. Initially, only reactants were there. So we have chosen A and B from our own side. It can be any value. That is why I have chosen A and B. Now the reaction proceeds. Some part of H2 will react with some part of I2 to give 2 moles of HI. So let us say that when equilibrium is established, out of A moles, X moles of H2 is reacting. So out of A moles, if X moles of H2 reacts, then out of B moles, how many moles of I2 will react? Tell me. According to the molar ratio of 1:1.
X moles.
X moles only. Because they will always react equally. So what will be left at equilibrium? B minus X moles. And how much of HI will be produced? Tell me. If this is you are taking X, this is also you are taking X, then how much of HI will be produced?
Twice X.
Twice of X. Is this understood? Have you understood this point? Yes or
sir.
no? Okay. Tamane, not the whole of A or whole of B are reacting because it's not an irreversible process. Only a fraction of it is getting converted to the products, and that fraction has to be equal because according to the molar ratio they are reacting. So if we assume that out of A moles, X moles of H2 is reacting, then out of B moles, exactly same moles of I2 will be reacting, and the HI produced will be 2X. Total moles at equilibrium will be A minus of X plus B minus of X plus twice of X, which comes out to be A plus B. So this is the total moles of all the reactants and products whosoever are present at equilibrium. So that comes out to be A plus B. Now, let us write the expression for Kc. So we know that Kc will be concentration of Hi square, concentration of H2 into concentration of I2, which is equal to number of moles of Hi by volume number of moles of H2 by volume number of moles of I2 by volume. So volume does not play any role because volume will be mutually getting cancelled. So this comes out to be 4x square by A minus X into B minus of X. Any part which is not clear, please do ask me.
আমি ভলিউমেডিকো ডিভাইড করলো
কারণ third bracket মানে concentration and definition of concentration is moles per liter. So moles to আমি লিখিছো, but it has to be divided by volume na, then only it is converted to concentration. ঠিক আছে?
yes sir.
আৰু গোটেইকেইটাৰ ভলিউম একে হ'ব because all of them are present in the same vessel. So vessel or volume to লোৱা হৈছে, which will be same for all. Clear?
Yes sir, clear.
Okay. Now let us try to write down the expression of Kp. Kp expression to আমি লিখিবলৈ চেষ্টা কৰো. Now Kp is nothing but it is the ratio of partial pressure of Hi square by partial pressure of H2 into partial pressure of I2. There is a relation that you will come across when you do the states of matter chapter. When there is a gaseous mixture, এটাতকৈ বেশি gas যদি থাকে, non-reacting gaseous mixture, then everyone will contribute to the overall pressure. And the pressure exerted by any one component in presence of others is called partial pressure. তার মানে তিনিওটা গ্যাস ইকুইলিব্রিয়ামত একেলগে pressure exert কৰিছে. The pressure exerted by Hi in presence of others will be called partial pressure of Hi. The pressure exerted by H2 in presence of others will be partial pressure of H2. So likewise, partial pressure is calculated using the formula partial pressure is equal to mole fraction into total pressure. Remember this relation. What is partial pressure? Partial pressure is the product of mole fraction into total pressure. What is mole fraction? It is number of moles of a particular component divided by total number of moles. What is the number of moles of Hi at equilibrium? 2x. What is the total number of moles at equilibrium? A plus B. So A2 whole tomar mole fraction of Hi. Let the total pressure of the system be P, capital P, so we square it off. So in place of PHI, I have written mole fraction of HI into total pressure of the mixture divided by. Can you tell me what expression should I write for PH2? Same way. What is the number of moles of H2 at equilibrium?
A minus X.
A minus of X. And what is the total number of moles at equilibrium?
A plus.
A plus B. And total pressure is same for all. Similarly, it will be B minus X, A plus B into total pressure. Clear? So those who have confusion regarding this, let me tell you that partial pressure of any gas in a mixture of gases may be written as product of its mole fraction into total pressure. Now, if you solve it out, what do you get? Tell me, will it not be same as that of Kc? See? Will it not be same as that of Kc expression?
Yes, sir. Yes, sir.
Why the Kp and Kc expression is same for this particular equation? It is because the change in the number of moles is 0. So we know that Kp is equal to Kc into RT whole to the power delta Ng. If delta Ng is 0, then RT to the power 0 will be 1. So Kp and Kc expression will be same. Clear or not?
Yes, sir.
So this is how we can get the relation for the first type of reaction in which delta Ng is 0. Now, if delta Ng is not 0, let us choose another example. If delta Ng is not 0, so let us see what are the expressions of Kc and Kp. Let us try it out. So we take type 2, N2 gas plus thrice H2 gas, reversible twice NH3 gas. At T equal to 0, let us say it is A moles, B moles is nil. So at T equilibrium, if this is A minus of X, how much we are supposed to write under H2? Tell me.
A B minus thrice X.
B minus of 3x. Why have I written 3x? Because the molar ratio is 1:3. So nitrogen pa jodi x moles jay, hydrogen pa 3 gun besi jabo, because the ratio says so. And what we are supposed to write under NH3?
Twice X.
Twice of x. So bhalke sailoba, this ratio and this ratio matches or not? The 1:3:2 ratio must be present. Total moles at equilibrium. A minus of x, B minus of thrice x. So this comes out to be A plus B minus of 2x. So this is the total moles at equilibrium. What is the Kc expression? Third bracket NH3 square, third bracket N2, third bracket H2 cube. So we are dividing by V as usual. So when you solve it out, I hope this is the expression that you will be getting, isn't it? Is it okay?
Yes, sir.
Kp, partial pressure of NH3 square, partial pressure of N2, partial pressure of H2 cube. The same way, in place of partial pressure, you will have to write mole fraction into total pressure. 2x by A plus B minus of 2x into total pressure. A minus of x, A plus B minus 2x into total pressure. B minus 3x, A plus B minus 2x into total pressure. So when you solve it out, what you are going to get is 4x square into A plus B minus 2x. This will be cube. A minus of x whole cube into p square. So expression wise, you see that no longer Kp and Kc are same, obviously because delta Ng is not zero now. But what I want you to learn is how to get the expression for Kp and Kc for any reaction. I hope you have understood the steps involved in the process, how to get the value of Kc and Kp.
Yes, sir.
So no matter whatever reaction is given to you, equation is given to you, you should be in a position to write down the expression of Kc and Kp. I hope it is clear.
Yes, sir.
So both the equations that we have discussed today, whether it is H2 plus I2 reversible twice of Hi, or whether it is N2 plus thrice H2 reversible twice of NH3, both of them have one thing in common, that both are association. Association means two molecules joining in to form a single molecule. So next class, we will take the third type of reaction where the molecule will be dissociating. A large molecule will be breaking down into groups of 2 or 3, whatever it is. And when we deal with equilibrium involving dissociation, so we are going to introduce a new term called degree of dissociation, which we will discuss the next class. So I end up the class here. All of you take care. Bye bye. Good night.
Bye bye, sir. Good night, sir. Thank you,
Thank
sir.
you, sir.